This week in Physics Lab, we observed magnetic fields of small permanent magnets with a compass and observed its nadals. We created a sketch of the magnetic field that we observed. Since both sides of the magnet are polar, depending on which side of the magnet is facing the compass, a specific needle will follow its suit. This demonstrates how opposites attract within a magnetic field.
So right now we have our two magnets that we are going to play with and try and sense the force of attraction or repulsion. So depending on what side you're playing with the magnets, each side has a north and a south. So depending on what your other magnet is, depends on whether if it's going to repel or attract. So we'll take these two and put them together. The force pulls it together and they attach. Then I'm going to flip this one so we have a different end. And you can kind of see it, but I can feel it pulling away from each other. So we know that these are a north and a north or a south and a south.
We wound the coil of a wire and put a DVM across the head. We moved a magnet around and inside the coil to prove that a magnetic field produces a current that is readable on the DVM. For the second part of this activity, we wrapped a coil wire around a nail and attached it to a battery. This allowed us to create our own magnet. We chose to demonstrate its magnetic field by showing how our compass needle was affected by the nail coil wire magnet that we ended up making. Here we tried our best to make a homopolar motor by connecting a copper wire, a magnet, and a battery together. We understand that the wire was supposed to move around the battery and the magnet, but we could not get our currents correct, so it didn't end up moving for us. Here we made a real motor with armatures and commutators. We connected copper wire into a block of foam, made our commutator there spinning in the middle, added a magnet, and connected a battery to our setup using a red and a black wire. And we were able to watch our commutator spin, which was awesome since this took us quite a bit of time. Next in this video is a fabulous demonstration from our TA about the eddy current.
Because when it's moving, when this magnet is moving, it's creating an opposing current. So this aluminum bar is not letting this strong magnet to go downward. It's creating an opposite force, which is called Lenz's law, and the current is named eddy current. Okay.